Assalamu alaikum everyone, this is Shakil again, and in this video lecture I'm going to share some very important information about graph making. Keeping in mind, graph making is one of the most important and challenging things in AS level physics practical. So here is the question related to tomorrow's practical. You have to plot a graph of t square on y-axis against x on x-axis, and then you have to draw a straight line of best fit. Before we move to the graph, let me tell you uh, the method or the steps to plot graph accurately. Okay, so beta, first of all, the first step in graph making is labeling axis, like x-axis and y-axis. And how you have to label it, you have to first write the quantity, the symbol of quantity slash unit, because this is carrying 1 mark, right? If you will not do this, you lose 1 mark. Second is beta scaling. This is the most challenging thing, scaling axis. What is meant by scaling axis? Scaling axis means that giving a value to every big square that is having 10 by 10 small squares. Okay, uh, this is challenging. We have to look upon this. So how to scale the axis? Let's look upon the method, right? Okay, so before we look upon the scaling method, let me draw the table because you will be using the values from the table. So let's say this is serial number, this is X, and then beta T1, T2, T3, average T, of course, unit will be with every quantity, then T and then T square. Okay, so beta, this is a rough draft, not using a ruler, just to save some time. Okay. So 1, 2, 3, 4, 5, and 6 readings are there. What's the main thing? The main thing is, let's say X is 5 centimeter, and then what was the last reading? Let's say it is 55 centimeter, and I'm skipping all the other values. Okay, and I am skipping these values as well, and T as well, but let me just make T square, right? So let's say T square is almost, uh, you can say, it can be any value, but let me just keep it 1.50, right? And then uh, this is suppose this is 0.80. These are the supposed imaginary data, right? Because this is supposed data because we have to make graph, so we need data. So you will take data tomorrow in the lab, but of course I have to write the rough data. Okay, so how you will scale the axis? Scaling means giving a value to every 10 by 10 big square. Let me tell you that. Look, I have labeled y-axis with t square with this unit, and I have labeled x-axis with x with its unit. Okay, beta, along x-axis there are 8 big squares. 8, like 1, 2, 3, 4, 5, 6, 7, 8. And along y-axis beta 12 big squares are there. 12 big squares are there. And beta in each big square 10 small squares are there. And this is the origin. It can be 0 or it cannot be 0. So let's just remove it. Okay, what you have to do is you have to label the values. You have to write the values of x over here, right? And then in the similar way, you have to write the value of t square over there, right? So what we have to do, what is the important thing to learn over here? We have to write values in such a way that more than 50% of graph along both axes should be covered. right? More than 50%. Like the uh, okay, let me explain you that over here. Okay, for scaling beta, let's first scale x-axis. So what's the method? The method is, what you have to do is you have to um, choose a scale range, scale value range. And beta, this range consists of uh, a minimum scale value and then a maximum scale value, a minimum scale value and a maximum scale value. Okay, so how can you find minimum scale value? This is this is the formula: maximum of the quantity minus minimum of the quantity divided by number of squares. Like along x-axis n will be 8 and along y-axis n will be 12. And maximum quantity mean the quantity that you are plotting along x-axis. You have to take its maximum value minus its minimum value. Okay, so that's how you will get the minimum scale value. For maximum scale value, you simply have to multiply minimum scale value with 2, so you will get the maximum scale value. So by doing that, you can get the scale value range. So let me work it out for x-axis. For x-axis it is x, so let me scale value range. Let me find that. So beta, what's the maximum? First I am applying this thing. What's the maximum value? It's 55. Minus what's the minimum value? It's 5. Divided by how many squares are there? 8, right? So it is 50 over 8. So what's the answer for 50 over 8? It is around 6.25. So it means your minimum scale value is 6.25, and for maximum you simply have to multiply it with 2, so that will give you 12.50. So this is your maximum scale value. It means your scale value range for x-axis, scale value range for x-axis is 6.25 to 12.50. It means you can choose any number between these that will represent the value of one big square. But one important thing is over there, that don't pick 3, 7, 9 as scale value, right? You can pick other numbers. The ideal numbers are like 2, 4, 5, 10. So for okay, what do you say? I guess 10 is fine because 10 is falling in it. So over selection, what is over selection? Over selection is 10 because like this is having 1 0, so this is an ideal number. So what is meant by 10 now? 10 means that you will be keeping a value of one square along x-axis as 10, right? So let me write down the value. We are starting from 0, so this is 10.0, this is 20.0, 30.0, 40.0, 50.0 and 60.0 because our last value is 55. Okay, now let's move on to y-axis. Let's move on to y-axis now. Okay, so for x-axis we are done. What you have to do is you have to perform same thing for y-axis, right? So same thing for y-axis, you have to plot t square along y-axis. So what's the maximum value? Like this is the minimum value and this is the maximum value. So 1.5 and 0.8. So I have to move uh, move to the next thing. Okay, just okay, I have to free some space over there. Okay, so let's move on. Let's do work on y-axis scaling. Y-axis scaling. Okay, beta, for y-axis scaling, you will repeat the same thing. Scale value range is minimum scale value and then the maximum scale value. Beta, for minimum scale value, your formula is maximum of the quantity that is plotted along y-axis minus minimum of the quantity that is plotted along y-axis over number of squares. And for maximum scale value, it's the same, minimum scale value into 2. Okay, just apply it. So what is maximum scale value? It was 1.50, minimum was 0.8, and n was 12. So just solve it. It's 0.70 over 12. And what should be the answer? 0.06, around, like around 0.06. Okay, it's less than 6, but let's keep it 0.06. Okay, what's the maximum value? That is 0.06 into 2. So it should be 0.12 seconds. So it means your scale value range for y-axis is 0.06 seconds to 0.12 seconds. What you have to do next is pick one number from it. Next, what you have to do, pick one number from this range as scale value. So what's your number? My number is 0.10 because 0.10 is falling in that range. So it means along y-axis, you have to keep value of each square as 0.10. But here is another important thing. What is the least value of time? Least value of time. In my data, it is 0.80 seconds. So I'm not supposed to start the origin from 0. So start origin value closer to your least value. Like don't start it from 0 always. We have started x-axis from 0. Why? Because the minimum value was 5, right? So minimum value was 5 and 5 is closer to 0. That's why I can take 0. But for y-axis beta, the minimum value, look at it, the minimum value is 0.80. So if you plot it like this, from 0 and 0.10, 0.20, 0.30, 0.40, and then moving on 0.50, 0.60, and moving on 0.70, 0.80. Look, your first point would be plotted over here, and then 0.90, 1.0, 1.1, 1.2. Even your data would not be falling in on it, because look at the value, your maximum value is 1.5. It means that you are not always supposed to start the origin from 0, right? This time you will be looking upon a number that is very close to your least value. Even you can start from the least value like 0.80. So you can start origin from 0.80 as well. Okay, so let me start it from 0.70, let's say. So then I have to keep scale value as 0.1. So 0.90, 1.0, 1.10, and then 1.20, 1.30, 1.40, 1.50, 1.60. So beta, now my scaling is completed, right? So this was the scaling thing. Scaling thing is very important. I have rushed through everything, but I have shared everything important. Okay, why scaling is important? Why scaling is important? Beta, keep one thing in mind. Whenever you have to make a graph, make sure that the distance between, let me tell you, this is x-axis, this is y-axis. Okay, suppose this is your first point, and suppose this is your last point, and some points are there in between as well. What you have to do is, between last point and first point, you have to count how many squares are there along x-axis. And from first point to last point, you have to look how many number of big squares are there. So as there are 8 big squares along x-axis and 12 big square along y-axis. So nx should be greater than or equal to 4 and ny should be greater than or equal to 6, only then your graph would be considered as correct. And this is also considered as whenever you have to make graph, you have to make sure that you are covering more than 50% of your graph, like 50% along x-axis and more than 50% along y-axis. So why we do scaling is, and why we have used the range method is, this is known as range method of scaling. So why we are doing range method of scaling, just to make sure that our graph should be covering more than 50% along both axes so that we can secure full marks. So that was the thing for the scaling. And now the next video would be about plotting the points and making the best fit line and the gradient calculation. But I will make that video tomorrow and I will share it, right? So take care, everyone. See you tomorrow, inshallah.